Assalamualaikum warahmatullahi wabarakatuh and greetings to season chair and other participants. I, Muhammad Saiful Hakim bin Saiful Bahari with my supervisor Dr. Lucianti Mazlan from School of Electrical Engineering, College of Engineering, University Technology Mara would like to present our study which is distracted driver detection using deep learning. As introduction, accidents and other fatal road crashes have become a central issue around the worldwide. As in a study shown in 2019, more than 1.35 million people die per year on the world highway. Driver behavior contribute the frequency pattern of the road crashes, such as cell phone using, talking to passenger, and adjusting radio. These are the common behavior that contribute to the road crashes around the worldwide. In this modern era, researchers have shown interest in the development of detecting distracted driver using deep learning. As a certain development such as ADS or known as automatic driver assistance system are being designed to keep drivers safe, but it also requires human to control emergency cases. So in order to provide a safety precaution, we need to notify the driver at the early stage of distracted behavior. As the problem statement in this study, there are two problem statements that have been identified. First, the rate of road crashes and accidents due to distracted driver behavior, especially when looking elsewhere, are high. And the second one is certain distracted driver detection system uses are still in early stage of development, and there's a lot of room and space for improvement. Based on the problem statement that have been identified, we come up with a research question and research objective of the study. So the research question of the study is what are the components that we use to detecting distracted driver detection, how to develop distracted driver detection, and what is the performance of distracted driver detection system. So there are three research objectives based on these questions. So first of all, to identify the components and process used in detecting distracted driver behavior. Second, to develop distracted driver behavior detection that use deep learning algorithm. And lastly, to measure the effectiveness of distracted driver behavior detection system with deep learning algorithm. As for methodology part, this is the overall block diagram for distracted driver detection using deep learning. As for the start of the process, we collect the data from datasets, then we go to some image processing, then we build the convolutional neural network, and finally, we do some behavior analysis. These are the example of datasets that have been used uh, in detecting the distracted driver behavior. The dataset have been obtained at the Kaggle State Farm datasets. The dataset contain 10 classes of images up to 22,000 number of images. So there is one classes that classify as the safe driving and other classes classify as looking elsewhere. These are the conceptual diagram and the flowchart of distracted driver detection using deep learning. As the start of the process, the images of distracted driver looking elsewhere are obtained from the datasets. Then the images go through some pre-processing step, which is image resizing and grayscale. This is to remove unnecessary information in the images and to be fed to the CNN algorithm, which is ResNet 50. Then training and testing of images have been done in the CNN algorithm. Then classification of distracted driver images. If the driver look elsewhere for video detection, the red tag of uh, the right type of distracted driver will be shown at the top of the image video. When the driver doesn't look elsewhere, green tag will show at the top of the video. And finally, we evaluate the effectiveness of the distracted driver detection system. For effectiveness evaluation, we use four tools, which is accuracy, precision, recall, and F1 score. Accuracy is defined as the classifier ability to select all cases that must be selected and reject all cases that must be rejected. Precision is defined as the percentage of cases discovered that were actually relevant. Recall is the proportion of relevant cases that were actually found among all relevant cases. And the F1 score is combine a classifier precision and recall into a single metric by taking their harmonic. As for result, it has been divided into two parts, which is preliminary study and actual study. For preliminary study, it has been used pre-trained ResNet 50 model that have been trained on ImageNet with using of 70% of training and 30% of testing data. We get low performance of distracted driver image classification. The performance, which is accuracy and precision, only achieve 66%. I recall only achieve 62%. For F1 score, only achieve 0.61. For actual study, we have used ResNet 50 model that have been coded from scratch. Also, same with preliminary study, we use 70% of training and 30% of testing data. We get high performance of classification of images, which is 94%. And the F1 score of the actual study also achieved 0.94. As for model accuracy and model loss, we can see for model accuracy, it can be keep increasing, passing 90%. For model loss, it keep decreasing until minimum value. This show this model in a good sign of image classification. As for conclusion, the goal of the research is to create and test a system that recognizes distracted driver behavior, such as looking away from the road. Result shows that the system meets the objective and correctly classifies the subject with 94% accuracy rate. Video used to detect distracted driver in vehicle also shows a positive outcome of detecting and classify the distracted driver behavior. For future recommendation, different CNN models with a different image pre-processing approach can be used to evaluate the performance of distracted driver detection. Other than that, looking in detail the classes that contribute high level of danger when distracted while driving, such as texting and talking on the phone, can be considered. That's all from me. Thank you.